On Friday, we looked at a new kind of plot called box and whisker plot. Today, we are going to be looking at stem and leaf plots, and we're not going to be drawing flowers or plants or anything on it, unfortunately. Okay, so let's first... Okay, so the first thing we want to do is define what a stem and leaf plot is. Okay, so a stem and leaf plot uses, let me zoom out a little bit, uses the digits of each number in a data set. So you're going to have like a list of 50 numbers, and a stem and leaf plot is a way of condensing all those numbers. So we're going to use each number in a data set to group the individual numbers. So we're going to group numbers, usually in increasing order. So that means the smallest first and the biggest last. So the stem and leaf plot uses digits of each number in a data set to group the individual numbers. And usually we do that in increasing order. Increasing. So we start with 0 and we end at the biggest number, whatever it is. Okay. So what is the leaf part? The leaf part represents the right-hand digit in each data. Okay. So the leaf part is the right-hand digit in each data set, so that is the ones place, right? So the leaf is the one place. So what's the stem? The stem represents the remaining left-hand digits. So sometimes your stem might have more than one number in it, okay? So your stem is the tens, the hundreds, the thousands, the millionths place, okay? But the leaf is always just one digit, the ones place. Does that make sense? Okay, so this is what it looks like. In example 1, okay, the stems, you always set it up as a T-chart. Whenever we draw a chart or a plot, we always title it whatever the data is. In this case, it's listing the number of minutes spent doing homework. Your stems these are all tens places, and your leaves are all the ones places. So my first value is 21. So let's, just so that we get an idea of what each of these means, let's list all of the values here. So the first one is 21. What's the second value? 22. 26. 29. And 29. So the way stem and leaf plots work is the top part is listing all the 20s first. So what do you think this one's listing? All the 30s. So this is what? 32, 32, 35, 36, and 38. Does that make sense? Okay, so will you guys list all of the 4 stems for me? Okay, so what's the first 4 value? 43. What's the next one? 45, 45, 45, 47, 48, and 48. Okay, what about the 5 stems? Is there a 0 there? No, there's nothing. So is there any 5 values? No. Okay, so we list the 5 value even though there's nothing in there to show that there is no 5. So if there was a 50 value, it would say 50. Because there's nothing there, there are no 5s. So we move on to 6s. What's the only 6 stem? 65. Okay, so if there is nothing listed, there are no 5s. If we had a 50 there, it would be 50. Does that make sense? So 0 will be listed. Okay, if there's nothing there, that means there are nothing under that stem. Okay, so what we're going to do is we're going to use the stem and leaf plot to answer some questions about this specific set of data. Now, when you have a stem and leaf plot, you do not need to list all the values. Otherwise, what's the point of the stem and leaf plot, right? The reason why I had you guys list is just so that you understand how to read it. Okay? So you do not have to do this every single time. You can just get the data off of them and leave. Okay? So let's answer some questions. First of all, how many students were asked how much time they spent doing homework? How many leaves do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? So that's all we need to write, 18 students. So the number of leaves is how many people were included in the data. Okay? What was the least amount of time spent on homework? Who spent the least amount of time? 5. What's the least amount of time listed here? 21 minutes, right? That smallest leaf. Okay, now listen to this question very carefully because I don't want you to get confused. What amount of time was spent doing homework the most? Not what was the most amount of time, what amount of time was spent the most? So which number occurs the most here? 45, right? We had 1, 2, 3, 45. So 45, more people spent 45 minutes than anybody else doing homework. Do you guys remember what that's called? The number that occurs the most? The mode. We are going to do mean, median, and mode in just a second. Okay, last question. How many students spent more than 45 minutes doing homework? We had someone with 47, 48, 48, and 65. So that's how many? 4 students. And that's all we have to do to get data off of the stem and leaf plot. Definition of mean. Mean is the sum of the data values divided by the number of data items. What's another word that we use for mean? Average. So mean and average are the same thing. We take all of the data and add them up, and then divide by how much data we added up, right? What about the median? Median kind of sounds like what? Middle. So median is the middle value of an odd number of data items. So when we have an odd number of data items, we just find what the middle one is after we arrange them in order from smallest to biggest. What happens if we have an even number of data items? Do you guys remember? We take the 2 middle, add them up, and then we divide by 2. Good. So we take for an even number of data items, the median is the mean of the 2 middle values. So we take the mean of the 2 middle values when we have an even number, which means there's no exact middle. Okay, what about mode? Mode is always the easy one to remember because it sounds a lot like most. So mode is the number of values that occur most often. When all of the data values occur at the same number of times, there is no mode. So if we have a data value that all my data values occur the same number of times, nothing occurs most often, then there is no mode. Can I have more than one mode? Yeah, I can. Okay, if they're the same amount of times. Okay. Example 2. Last example. It has to do with mean, median, and mode. The table below shows the number of games won by the Fresno Grizzlies and the Sacramento River Cats. So from 2005 to 2009, the Grizzlies won this many games of the games they played, and the River Cats won this many games of the games they played. So then we're going to answer some questions. What is the mean number of Grizzly wins? So I need to take all the Grizzly wins and add them up. So that's 68 plus 61 plus 77 plus 67 plus 71. When we add all of those up, because I already did it, we get 344. 344. And then what do I do to find the mean? I take 344 and divide by how many scores I added up. How many did I add up? 1, 2, 3, 4, 5. So 344 divided by 5, which gives me 69. So the mean number of wins, the average of all of their wins was 69. So you guys, I want you to do part B, find the mean number of River Cats wins. Okay, so to find the mean number of River Cats wins, what do I need to do first, Jaime? Add all of them up. So I'm going to add up 80 plus 78 plus 84 plus 83 plus 86. What did that give you? 411. Good. Okay, so that's the mean, right? No, Alana, what do I have to do? Divide 411 by 5. So what did you get? 82. Good. So, on average, who won more games? The Grizzlies or the River Cats? The River Cats. So part C. What is the median for the number of Grizzlies wins? Well, in order to find the median, first I have to list all the wins in order from smallest to biggest, right? So let's list them all in order. What is the smallest number? 61. What's the second smallest? 67. Then 68. Then 71. And then 77. Okay, so which one is this middle one? I always start at the two ends and kind of just work my way in. So those are 1, 2, and the middle number is 68. So the median number of wins, 68. So what's the median number of River Cats wins? Let's list them all in order. Smallest is 78, 80, 83, 84, and 86. The middle one is 83.